Okay, so we've now reached our fourth lecture, and so far we've focused on prices, and we saw that market prices are determined by the interaction of consumers and suppliers. And when we thought about consumers, we just said, when the price is lower, people tend to buy more. And when we talked about suppliers, we said, when the price is higher, suppliers tend to supply more to the market. Actually, behind each of those two statements is a world of thinking. So what we're going to do is now go back to consumers and think more carefully about what drives consumer behavior. When we've done that, in the next few lectures, we'll think about supplier behavior and try to understand more about what drives suppliers to do what they do. But for now, for this lecture, we just concentrate on consumers and think a bit more behind the demand curve. Now, there are different ways that we can approach this, but one way which will give us insights into the way in which people behave is approach called utility analysis. Sometimes it's called, for reasons we'll see in just a moment, marginal utility analysis. And remember that what we're trying to do here is to see if we can understand why consumers behave in the way in which they do. Now, why do people buy anything? They buy it because the good that they buy gives them some sense of satisfaction, some sense of well-being, something that they get out of it, which economists call utility. One of the problems about utility is it's difficult to measure it. How many degrees of utility do you get from that last glass of wine? How many degrees of utility do you obtain from the holiday that you took? It's very difficult to quantify it. But for the purposes of this approach, I'm going to assume that we can do that and that you can compare different goods that you buy by saying, this one gives me 20 degrees of utility, this good gets me 10 degrees of utility or whatever. So that's going to be my assumption as we try to make sense of why consumers behave in the way in which they do. Okay, now, what's the relationship between the amount of goods that you buy and the amount of utility that you get? And I'm going to focus first of all upon just one particular good and ask you, as you consume more of the good, what happens to the utility that you get from it? In general, I think, for the great majority of consumers, for the great majority of goods, the answer is this. If you don't buy anything of a good, you get no utility. As you consume more of it, your utility rises. You prefer more of a good to less. But the rate of increase of utility as you increase consumption tends to decline. You buy a Big Mac and it gives you some utility. But if you buy a second Big Mac, it doesn't add so much to your utility. You've already had one. And so as you buy more, you may prefer 3 to 2 or 4 to 3, but the extent to which your utility is rising is getting smaller. Let's plot that on a diagram. Here we have the relationship between utility and the amount of units you consume. So at 0 units, you get 0 utility. Your utility increases as the number of units you consume increases, but I'm suggesting that it increases, but at a decreasing rate. So that for the vast majority of goods, the relationship between the amount you consume and the utility you derive looks something like this. Total utility, TU, rises, but at a diminishing rate. And it's very difficult to think of exceptions to that rule. One excellent lady economist I know tells me that it's not true for women and high-heeled shoes, but for the vast majority of goods, that's true. And you wouldn't expect consumers to consume more, even if they were able to, than the point at which total utility is maximised. You can think of a consumer buying more of a good and having so much of it, the stuff is just getting in the way, and utility actually begins to decline. You wouldn't expect a rational consumer to buy more than that which maximises total utility. You might reflect on whether that's true of students drinking alcohol, where they go on drinking the stuff until the point at which they get drunk and sick. But for most goods, total utility rises at a decreasing rate with increases in the amount of consumption. Now, there's another way of saying that which is going to be very important to us, and that's why I've drawn a second diagram underneath. What I'm going to draw underneath is not something different from what I've drawn on the top diagram. It's another way of presenting the same information. Underneath, I'm plotting the additional utility, the marginal utility that you get from increasing your consumption of the good. So one Big Mac got you 20 degrees of utility. 2 Big Macs got you 30 degrees of utility. 3 Big Macs got you 35 degrees of utility. And 4 Big Macs got you 36 degrees of utility. So utility rose, but more and more slowly. Now I'm going to plot the same information by asking what's the marginal utility. When you went from 0 to 1 unit, your utility rose from 0 to 20. Your marginal utility was 20 degrees of utility. If you had 1 and decided to have 2, utility rose from 20 to 30. You got an extra 10 degrees of utility from the second unit consumed. The marginal utility was 10 on that second unit. On the third one, it went from 30 to 35. The third unit got you an extra 5, and the fourth one just an extra 1. So marginal utility declines. That's another way of saying total utility rises more slowly. If the next unit of the good gets you no extra utility, total utility stays the same, well then by definition, marginal utility is 0. You get no extra value out of, in my case, that fifth unit. When total utility is maximized, marginal utility is 0. Now we can use that idea to begin to understand why consumers behave in the way in which they do. If you could imagine yourself with a limitless income, or that prices were 0, and you could consume whatever you liked, then the rational consumer would consume all goods up to the point where total utility is maximized, or to put it another way, until marginal utility is 0. But the great majority of us can't do that. And the reason we can't do it is that our preferences are constrained. And they're constrained partly because we have to pay for these goods, partly because we have a limited income. So how do we think that a consumer maximizes their total utility when they have to do it by operating with their preferences, but with prices and with a constraint imposed by incomes? That's what we want to see. How would a consumer behave under those circumstances? And the way we'll do it is like this. We'll assume, for the purposes of illustration, that there are only 2 goods that you're interested in consuming, and they have different prices, and you wish to arrange your expenditure to maximize your utility, given the utility you consume from each one, given the constraint of your income and prices. How do you distribute your expenditure to maximize your utility? Now, the principle that we're going to establish is one which would hold regardless of the number of goods. But it's easier to see what's going on and why if we make a simplifying assumption that there are only two goods in which you're interested in. So that's what we're going to do now. Set up a little problem. You have limited income. You have to pay a price for each of these goods, but your utility, your preferences are known. How do you distribute your expenditure? Okay, well, here's my little example that we'll use to illustrate the problem. You're interested in only two goods, good A and good B. The more of A you consume, the higher is your total utility. You prefer more to less. But as we saw before, utility is rising at a decreasing rate. So marginal utility is declining. If you consume 1 unit, total utility is 11. At 2, it's 19. Then marginal utility, the difference in total utility, is only 8. Increase consumption by another unit, total utility rises to 25. That is to say, you get an extra 6 degrees of utility from the third unit, and so on. So good A exhibits the characteristics that we've been describing. Now, what about good B? That also exhibits the same characteristics. As you increase your consumption, utility rises, but at a decreasing rate. Or put that another way, marginal utility falls. Now, the amount of utility that you get from each good is different because they're two different goods. But the principle of a diminishing marginal utility holds for both goods. If you had zero prices, limitless income, you would simply wish to buy all you could of both goods until marginal utility is zero. But I'm going to make some assumptions now, and the assumption I'm going to make is that you only have 10 pounds, euros, whatever, 10 euros a month to spend that you can allocate between good A and good B. And I'm going to assume that the price of A is 2 and the price of B is 1. How would you allocate your expenditure to maximize your total utility? How about this? Would you allocate your expenditure such that marginal utility on the two goods is the same? Suppose you were allocating your expenditure so that the utility you got from the last unit of A consumed was much more than the utility you got from the last unit of B consumed. Wouldn't you be better off by consuming a bit less of B, where your utility that you got from the last unit is quite small, and transferring it to A, where the extra utility is higher? And as you spent less on B, the utility you got from the last unit, the marginal utility, would rise. And as you spent more on A, the marginal utility would fall. Wouldn't you distribute your expenditure between the two goods such that marginal utility is the same on both goods? Let's check to see whether that's right. Let's consider the possibilities that are open to us with regard to our expenditure on the two goods. And I've got here all the possible combinations. You could spend all of your income on good A and none of it on good B. If you did that, you could buy 5 of A, because remember, A is £2, €2, whatever it is, £2 each. But what you could do is go for the other extreme and spend it all on B. You'd have 10 of B only costs £1 a go, and then you'd spend nothing on A. Or you could distribute your expenditure between the two goods so that you could have, say, 4 of A for £8, 2 of B for £1. Or you could have 3 of A for £6, 4 of B for £4, and so on. We've got the various combinations opened to us. And what I've got here is the total utility that you'd get with all these varying combinations, which suggests that the optimum combination for you is to buy 2 of A and 6 of B and get 54 degrees of utility. Let's come back to our original table and see where we got this sum of 54. 2 of A gets us a total of 19 degrees of utility, and we said we could have 6 of B, which would get us a total on B of 35 degrees of utility. Add that up, and you've got a total utility of 54, which is more than you could have with any other combination. So it looks as if our consumer would be best off with 2 of A and 6 of B. And I suggested to you that what that means is that you could think about it in terms of equating the marginal utility of each of the goods. Does that work? The marginal utility, the utility that you got from the last unit that you bought of A, marginal utility was 8. Is that the same as the marginal utility that you got from the last unit spent on B? The 6th unit got you 4 degrees of utility. Then we've got something wrong. It isn't actually true that the consumer maximizes their welfare by allocating their expenditure so that marginal utility on the two goods is the same. What have we got wrong here? Well, what we've got wrong is that we failed to take into account the price that we have to pay. We've worked out that we've equalized marginal utility, but are we saying we don't care what we have to pay for A or what we have to pay for B? This can't be right. No, we don't equalize marginal utility. We equalize the marginal utility of the last pounds that we spend on A with the marginal utility of the last pound that we spend on B. Let's come back to the figures and see that. The last unit of A that you bought gave you 8 degrees of utility, but it cost you £2. So the marginal utility of the last pounds that you spent on A got you 4 degrees of utility. Marginal utility divided by price. Now look at B. The last unit of B that you consumed got you 4 degrees of utility. What was the price of B? £1. So how much was the additional utility on the last pound's worth of B spent? 4, marginal utility, divide by the price, 1, 4 over 1 is 4. So what we could say then is that the way in which our consumer maximizes utility is like this. Our consumer spends so that the marginal utility of A divided by its price is equal to the marginal utility of B divided by its price, and that would be true if there were a C and a D and any others. In our particular case, the marginal utility of A was 8. If we divide by its price, 2. If we're maximizing utility, that will equal the marginal utility of B, 4, divided by its price, 1. 8 over 2 equals 4 over 1. Marginal utility divided by price is the same. The marginal utility of the last pound's worth of expenditure on the two goods will be the same if our consumer is maximizing well-being. Now, you might think that you're disinclined to believe this because when you've heard someone going around a supermarket, you rarely hear someone saying, yes, but is the marginal utility of that bottle of wine divided by its price equal to the marginal utility of that packet of washing powder divided by its price? You are describing something that people simply don't do. Well, I can assure you that it's exactly what they do, but they don't use the terms that I'm using to describe their behavior. When somebody goes around the supermarket and says, God, that wine's expensive, I'm not buying that. I think I'd rather have that meal for my tea. They're saying the marginal utility of the last pound spent on that good is less than the marginal utility of the last pound's worth of expenditure on that good. The fact that they don't think in terms of marginal utility does not mean to say that they don't do that. If you've ever watched David Beckham take a free kick, it's masterful. The ability to curve the ball around the wall into the top corner of the goal is a sight to behold. And he's using engineering and scientific principles to do it. If you asked him how he does it, would he describe what he's doing in terms of kinetic energy or whatever? He would say, I just kick the ball and it happens. But he must be using scientific principles or the ball wouldn't go in the goal. The fact that he doesn't use the same terms to describe what he's doing as the scientist in no way detracts from the fact that he is using those principles. In exactly the same way, consumers maximize their well-being by allocating expenditure such that marginal utility divided by the price is the same for all goods. The fact that they have never heard of the term marginal utility in no way means that they do not behave in this way. Now, coming back to this, we can begin to see the logic of why the demand curve is shaped the way it is. Let's come back to the numbers that we have here. Suppose the price of A increases and the price of A is no longer £2 but goes up to, say, £4. This consumer is no longer in equilibrium. Marginal utility divided by the price is not the same. How does our consumer restore equilibrium? Clearly this 8 is going to have to go up. How does marginal utility rise? It rises if you consume less of it. Total utility will fall, but marginal utility will rise. So the consumer reallocates expenditure so that as the price rises, marginal utility rises, and you raise marginal utility by reducing the amount consumed. Now, once you've seen that, you see that what determines the demand curve is marginal utility. If we look at the demand curve for an individual consumer, what we're looking at is their marginal utility. Let's see if we can focus on the demand curve and see that. Here's our consumer willing to pay a great deal for this first unit of the good. Why? Because the marginal utility, the utility you get on that first unit is high. But if you're going to buy a second unit, you're going to have a lower price for it because the extra utility, the marginal utility that you get from the second unit is lower. If you as a consumer are going to buy more of a good, the price that you pay is going to have to be lower because the demand curve reflects not the total utility, but the marginal utility of the good. Now, you can see the total utility. So if, for example, we were interested in the total utility gained from 3 units, we could say, well, it's the first. That first unit gets that much utility. The second unit gets that much utility. The third unit gets that much utility, so that the area that I've shaded represents the total utility, the sum of all the marginal utilities. But what determines the position of the demand curve is not the total utility, but the marginal utility that consumers get. So as demand increases, as we move down that demand curve, we're drawing more consumers into the market because what drives their behavior is not their total utility, but their marginal utility. So you could think of one demand curve of some individual consumer as reflecting his marginal utility. If you think about the demand curve for the whole market, then we can sum all the individual demand curves, all the individual marginal utilities to give us the total utility for the whole market. So what determines behavior is not total utility, but marginal utility. And that's going to be important as we understand consumer behavior. And it's also going to become important later on in the course when we think about how well markets allocate scarce resources. Now we can develop that idea a little more by thinking about our consumers for any particular product and seeing just how much utility is derived from the consumption of a good. So let's come back now to the diagram that we've got in front of us and understand what economists mean when they talk about the value of a good. When economists talk about the value of a good, they may mean one of two things which you can see from the diagram. We sometimes talk about the value in exchange. These consumers are buying, let's say, 10 units of this good. Supply and demand gives us an equilibrium quantity of 10 and an equilibrium price of, let's say, 5. Then consumers are buying 10 goods, units of the good, at €5 a time, price times quantity. This area, price times quantity, gives us the value in exchange. Consumers spend €50 on the goods. They exchange those €50 for the good. Suppliers receive a total amount of revenue of 50. 5 times 10, price times quantity. But there's another meaning of the word value that we can see from the diagram as well. This first consumer paid €5, but he would willingly have paid 10. We know that because the demand curve says, yes, that's how much utility it gets for me. If I had the choice of not having the good at all or paying €10 for it, that's what I'd pay. So he only had to pay €5. He got €10 worth of utility. He got €5 worth of utility in excess of the price he paid. We would call that his consumer surplus. This second unit was only valued by the consumer at, let's say, €8. But he only had to pay 5. He got some consumer surplus. Not so much. The difference between 8 and 5 is the €3 worth of surplus of value above what he actually had to pay. And so on. This consumer surplus is getting smaller as the marginal utility falls, until the total amount of consumer surplus for all consumers on the product is this area under the demand curve down to the price. That is the area that we call consumer surplus. So another way of defining value is to say that the total value to consumers of this product is all the utility, the sum of all the marginal utilities, the consumer surplus, plus what they actually pay, the value in exchange, plus the consumer surplus that we sometimes call the value in use. So you can see that the importance of understanding the demand curve is not simply thinking in terms of the total utility that you get from goods. It's important to see that what underlies decisions is the marginal utility. Once you've understood that, things become clear that might otherwise be a mystery. Let's take one example. Isn't it strange that diamonds, which are functionally fairly useless things, exchange at an incredibly high price, and water, which is of enormous value, it's so significant that it can save your life, exchanges at a relatively low price? How can we make sense of the huge difference in the price of diamonds and water? It seems to bear no relationship to what we've been talking about with regard to utility. Actually, once we've understood the difference between marginal and total utility, it begins to make perfect sense. Let's look at the market for diamonds and the market for water and see if we can explain this apparent paradox. Here's the market for diamonds. Supply and demand determines a price of diamonds at PD and an equilibrium output at QD. Here's the market for water. Supply and demand determines an equilibrium price of PW at a quantity of QW. Notice that the price of diamonds is much higher than the price of water. But we said that the utility of water must be much higher than the utility of diamonds, surely. Yes, it is, and we can see it on the diagram. What's the total utility to consumers of diamonds? It's all these marginal utilities. Marginal utility of the first, the second, the third, and so on. This area that we're shading in here represents the total utility of diamonds. What's the total utility of water? It's the sum of all the marginal utilities. This, plus this, plus this, and so on. The total utility of water is far higher than the total utility of diamonds. Water saves your life. Diamonds is functionally fairly useless. But notice that the price is not determined by the total utility. The price is determined by the marginal utility. And the marginal utility of the last diamond consumed is higher than the marginal utility, the utility of the last unit of water consumed. Think about it. What's the marginal utility of water to you? The utility you get from the last bit of water consumed, it's virtually zero. You leave the tap on when you clean your teeth. Whereas the marginal utility of a diamond is actually much higher. Price reflects not total utility, but marginal utility. So we've learned something valuable about consumer behavior, how consumers allocate their expenditure, and we've learned something which is going to be of great significance to us as the course develops, that when you look at a demand curve, the reason why the demand curve slopes downwards is because of marginal utility. The demand curve reflects marginal but not total utility. One of the key issues we'll want to look at in the course is to what extent does a market system maximize consumer well-being? And we're going to need this concept of marginal utility in order to answer that question. So we've come quite a long way. We've understood equilibrium prices. We've understood how markets adjust to changes in demand and supply. We've understood the extent to which they adjust through elasticity of demand and supply. And we've now got a pretty good idea about what drives consumer behavior. Soon, we'll turn to the question of supplier behavior. But so far, make sure that you understand the logic of the demand curve and what lies behind it.